Okay. Okay, let's go ahead then and get ourselves started with our class. And what we're going to be talking about today is continuing with the whole notion of doing building systems, all the different pieces of a building that help make it more than just an architectural form, but all the things that work together to actually make it more of a living organism. So we talked a little about kind of structural systems and how they work to go ahead and support our architectural form. Today we really want to start looking at the mechanical system, so the HVAC side, the air handling and moving equipment, the plumbing systems, a lot of the things that are actually just working behind the walls and above the ceiling to go through and provide the needed services, to kind of keep us all healthy and supplied with what we need within the building. So we're going to look at really two specific types of systems today. I'll start with plumbing and then we'll work at air handling systems. And really what I almost like to do to start with is think about just the building science behind it, because a lot of the challenge that comes when we're trying to go through and model these systems comes from just needing to understand the physics and the science behind how those systems work. Once we get that science down, putting the systems in place, doing the actual modeling is actually pretty easy. But it's more about just understanding what it is you're trying to design and what the constraints are around what you're trying to design. So to get us started, let me go ahead and open up an example, and I'm going to open up Revit. So to start over there, popping into Revit 2014. And we'll open up a model that includes some pretty well-developed systems for the plumbing and the HVAC system behind the building. If you want to follow along, go ahead and open up, it's under session 15 on coursework. You'll actually find there's a model that we uploaded, we didn't spend much time with last time. Let me find it on my own machine. I have it here hiding under Stanford 120 session 15. And the model file is, let's go ahead and start with the architectural model. Okay, now this model, when it finishes opening, let me go ahead and close some of these things, which we don't need just yet, is again a little architectural building. It's an example of, kind of a small building that might be some retail space with some office space above it. But in this little model, which we developed just really to illustrate some of these concepts, you'll be able to see, if you go up to like level 2 or any of the levels, there's sort of a core to the building. So if I zoom on in, you'll actually see there's what I'll call like a bathroom core. There's sort of a men's room on one side, a urinal, a toilet, a sink, a ladies' room with 2 toilets and a sink there. There's some just mechanical equipment that's back there, some plumbing systems that we want to go through and ultimately supply water to. We want to carry the waste away from them. We're going to learn how to kind of control those sorts of systems. We're also going to go ahead and take a look at the HVAC systems. The air handling that actually provides the fresh air to these spaces, as well as the heating and cooling as necessary to kind of keep them comfortable and within the right range of temperatures for what we'd like the comfort to be in the space. And let's just kind of talk about these systems a little bit and kind of what the design is like behind them. You'll actually notice even in this floor plan view, as we look at these bathroom spaces, you'll see that I actually have 2 walls set up right now. I have an inner wall and an outer wall. This is actually very common, especially in commercial construction, that we don't actually have enough room in the wall itself to go through to accommodate all the pipes. So we set up an interior wall and a little bit of space to accommodate the pipes and everything that needs to happen mechanically to support these fixtures. Now, this is not necessarily true in residential construction. In residential construction, we often have toilets where the drain is on the bottom and it goes down into the floor. Even the water supply, we typically just handle right within the 2x4 studs of the wall, just right within there. There's not so much that it cuts away meaningful structure. So we tend to do that just right within the wall. In commercial spaces, though, we often need a little bit more space. We'll have bigger pipes, we'll have more of them. If I have a whole series of toilets all gamed together, the wall-hung toilets will have a big drain pipe that needs to go somewhere. And if there's not enough space actually within the wall space, we build this interior wall, and and then run a lot of the piping behind in that little bit of a mechanical chase space. And you see this actually a lot these days. If you go into a lot of modern restrooms now, behind the toilets or behind the urinals, you actually have some sort of situation like this, where you have the main space. This is, we're looking at it in section, okay, where we have the wall and the floor. And what we'll actually have is a little bit of an interior wall, and then you'll have, the toilet kind of hanging to the wall. Okay. And there'll be like some sort of shelf back in here. And what's going on there? It's not just sort of an interesting architectural feature. What they're doing is actually providing a little space where the piping can come out the back of the toilet and have room to run. And by putting things into these little mechanical chases, it not only sort of makes it easier to route everything, it actually makes it easier to service anything, because if there is some sort of problem with the piping or the valves or just something that needs to be changed later, rather than having to tear into the tile and tear into the wall and mess all that up, these things are often set up so this top piece right there can be removed temporarily, and you can still get access to everything. So there's kind of a functional reason for doing that stuff too. But we often see things as more this double wall construction. Okay, let's go ahead and I'm going to open up a mechanical model that works with this architectural model, and that may be a good starting point. I'm going to open up, if I go to that same folder, and say that I want to take a look at an MEP model that goes with this. You'll see that I'm going to get a slightly different view here. This is a model which only contains the HVAC elements and only contains the plumbing elements. And you might ask, why do I go ahead and have a separate model for the MEP elements versus the architecture elements? Well, I really look for the point of doing that. It's just even make your life a lot more complex to separate these two things. The truth is, as we're going through and doing our design work, the type of design work that is done as part of the MEP system is often carried out by different designers than the architectural designers or even the structural designers. The structural designers often have their own separate file. The MEP designers will have their own file. In fact, there may be several different systems. There may be a designer who does just specifically the plumbing systems and how the sanitary sewer system works. There may be a very different designer who's actually doing the sprinkler piping, okay, and has responsibility for that. And the principle that we try to use is that everyone should basically have control of their own file, but not be able to change pieces of other designs that they aren't ultimately responsible and liable for. So what we tend to do is actually create lots of separate files, and we just link them together. We can pull them all together based on the same XYZ coordinates. So we can coordinate our work without actually giving you the ability to change someone else's work. Okay, it's much, much cleaner this way. It allows us to all work together, and there's no question that somehow, something you're responsible for and liable for might accidentally be changed by someone else who just doesn't even understand the impact of what that change may be. So it's very nice to be able to separate them into separate files. But how we get files back together, though, just so you know at a high level what's going on, is we'll link them together. And linking looks something like this. Let me zoom this out so you sort of get a sense of what we're going to do. Under the Insert tab, we have the option of inserting all sorts of things. We can insert CAD files like AutoCAD files, DWG files, or things from other kind of modeling applications. If it's a Revit file you want to insert, there's actually its own special button, and you can link to that. The nice thing about linking to a file is that it establishes a live link, so that if you're linked to a file, and if later on someone changes the file that I'm linking to, I'll always get the live version of it. Okay, so it's a dynamic link as opposed to just being a snapshot right now. I can say link. Linking looks so easy to do. Actually, let me go ahead and cancel, because it's going to, well, I'll try to show what I'm going to do, and then I'll tell you now I need to go through and fix something. You have these choices here of really how you want to link things together. And it's pretty hard to go wrong in this dialog, except for this choice right down here, which is unfortunately the default choice. Okay. There's this notion of really positioning the two different files together, and by default it chooses something called center to center. Let's think about what that is. In a center to center scheme, you think about each of the different files and the total extent of what's modeled in there, the total x, y, and z, the total extent. And if we put the center of that space, okay, then I have the MEP file x, y, z in the center of that space, and I try to bring those two centers together. Okay. The odds of actually having a coordination between things based on those two centers is actually incredibly small. Okay, because almost anything could happen to sort of extend the bounds in any one direction or change. Those things are going to move relative to each other. So center to center is actually, it's my least favorite way to link things. I tend to prefer to actually link by origin to origin. Origin to origin says, if we all agreed and set up the same XYZ 0.000 for that system, and we started all the files using the same origin, they will forever and always be linked at that same point. So it's a very nice, kind of very cohesive way of tying things together. So origin to origin is always one of my favorite ways. If you didn't do it that way, instead you went through and you created them separately, but you've actually figured out what the transform is between the different coordinate systems. And there's usually, you modeled it so your 0, 0 was in that corner, I modeled it so my 0, 0, 0 was in this corner. And I know that it's going to be 10 over and 20 off. Yeah, I can put that in there, establish that relationship once, then I'd be doing by shared coordinates. I can sort of set that up. But I don't want to do it typically by center to center. So I'll choose origin to origin. I'm going to get one little complaint about this whole process. It's going to say, you already had a thing open for editing, so if you're going to have it open for editing, I can't link to it at the same time. That's what it's complaining about here, and I'll close that because I'll live with that. I think that's a fairly reasonable thing to be told. Go back over, let me see if I can switch over to the architectural models. I'm just going to close it up so I can link to it instead. So, back over here in the architecture file, I'll just close that up. So I'm only looking at the mechanical file. And then within the mechanical file, what I can say is link. Again, choosing that. Always remembering to do the origin to origin. That's the one I always get myself in trouble on. And you'll see that magically the file shows up there. And with the linked architectural file, you can actually see a little bit about how this all fits together. We can sort of see that grayed out version of the main building file in the background. We can see these plumbing fixtures kind of laid out in the foreground, as well as some piping systems. Linked files have this attribute to them. Things that are in my main file, which in this case you can sort of see as being the ones with the darker lines, those I can actually do things to. I can choose them, get their properties, I can make changes, I can edit those files. The linked file, the big architectural model that's hanging in the background, if I click on it at all, you'll see I can't really make changes to it. I can select the entire thing and it goes blue. Okay, but I can't make individual changes to it. And if you even sort of hover over it, you'll see it has this big blue box around it. That's kind of my look but don't touch box. Okay, so whenever you see that, it means there's a valid object in there, there's things you can see and understand within there, you just can't get inside. Okay? And yeah, we'll live with that for now. Now, just to make it a little bit easier, I just want to show you how these things are related together. You can sort of see that though the models do come together, and we can start tying them together. But for what I'm going to do right now, I'm going to hide that linked model just to make it a little bit easier to see what's going on. So there's my linked model. I can see a little about, in the linked model, how the ductwork is actually related to the offices that are underneath it, how the piping is related to the bathroom space, how the main supply and returns are actually tied into an air handling unit kind of in the mechanical space. You can sort of see that together. But just to simplify our life, make it a little bit easier or clearer what's going on, we will go through and just turn those things off. So I'm going to say visibility graphics. And for the Revit link, I'm just going to turn that off right now. That's just going to hide it from me right now. It's still linked in. It's just turned off and no longer visible. So let's take a look at this, a little more plainly. I'm going to start with the mechanical or the plumbing systems, because I think those are pretty easy to understand. And you'll see in these bathrooms, they have a series of different fixtures that are all sort of tied together. And let's kind of talk about those fixtures and how we design a system like this. So as we think about designing a system like this, let me just draw the profile or an elevation of that wall. On that wall, I have a couple different fixtures. I have this toilet, which is kind of hanging around in here. I have another toilet, which is hanging around in here. Maybe there's a urinal. Those tend to be a little bit higher. Well, toilets in commercial spaces, just so you know, they're about 19 inches off the floor, at least for an ADA compliant one. Okay, residential ones are a little bit lower. So if you ever wonder why a toilet in a public space sort of feels like you're climbing up a little bit higher, you are. Then there's a sink over here, and a bowl on the bottom. Okay, so we got some different fixtures in here. For these different fixtures, if we think about how really the plumbing works for these, there are a number of different sort of inputs and outputs for each of these different fixtures. So the toilets, one looks particularly strange, have basically solid waste, some sort of sanitary waste that will come out of each of those. In fact, what will happen is all these fixtures do have some sort of wastewater coming away. It tends to be a different size for each of the different units. Big old commercial toilets tend to have a 4-inch out. Something like a urinal, it doesn't need to be as big as the 4-inch out because it's not carrying away solid waste, it's all just liquid waste. So those tend to be much smaller, maybe 1.5 inches. Even for the sink, it's probably 1.5 inches. And then all these wastes, we could go ahead and try and run these all individually over to a sewer somewhere, but we don't do that. What we tend to do is actually bring them all together into something I'll call a lateral of some type that actually brings them all into a single line and carries it away, the waste away. And as we think about that line, we don't run it laterally, at least in terms of like having it being perfectly flat. If we did that, we'd have a problem. Ultimately, the waste wouldn't flow downhill. So what we do is introduce a little bit of slope. So we'll kind of be heading on down. Okay, so how big should that line be is one question you might ask. It really depends on how many fixtures you have back up stream from it. With only 2 toilets, like if it's 4-inch outputs, this could probably still be 4 inches. If I had 12 toilets over here, it might have to actually be a little bit bigger. There's sort of this notion that if everyone flushed simultaneously, what's the worst case scenario you might run into? Okay, but often this will often be like 4 inches. The other thing you might notice about it is, there's this issue of the slope. For the slope, does anyone know what the rules are about sloping residential pipes? Or sloping like sanitary pipes? How much slope would you guess it has to have? Does anyone know? 2%. I think it may be 2%. I think of it in terms of a ratio to per foot. Okay. I always think of it as being 1/4 inch per foot. Okay. I've heard this morning that it could actually be as low as 1/8 of an inch per foot, but 1/4 of an inch is a little more slope. That's more of a recommended as opposed to a minimum or something like that. So what that means is for every foot going this way, every 12 inches, this has to go down about 1/4 of an inch. Yeah, that's not too awfully bad, but it's not perfectly flat either, and that actually kind of creates some challenges for us sometimes. So we're going to tie these systems all into that. Ultimately, this line is going to come running along. What's going to happen is we're going to need to get from these individual units, carry this waste through the lateral to the sewer, and that'll typically happen through somewhere all the laterals on different floors will join together. We'll have some vertical pipe that this all gets teed into, and it looks very squishy, only because I ran out of whiteboard space. It has to be bigger still. Okay, I'll call this a riser. Okay, so that's a riser. This guy over here I'll usually call a lateral. Okay, and that's how the waste system gets carried away. Now, we have the whole issue of the sanitary waste. Let's think about the other things that are hanging around in here. Okay, for these different fixtures in the bathroom, like who needs hot water? pretty much only the sink. So this is going to have some sort of hot in. Okay, we'll have to supply something there. It's typically a 1/2 inch line, but it could be a 1 inch line. It really just depends on how much flow you have, how much pressure you have in the system. Okay. Interestingly, we don't always have hot water supplied by a central system. In a lot of commercial applications, we'll have a little mini water heater just right underneath the sink that's supplying the hot water as opposed to doing it from some central boiler. So we can go either way on that. Cold water at the sink, cold water feeding some sort of flush valve on each of these. Okay, and there's a certain amount of flow for each of those different things, but that's the basics of the plumbing system. And the way you'll start to think about it is we have a certain number of outs, we have a certain number of ins, each of them has a certain capacity or a flow they have to deliver, and as we work with the pipes, we sort of lay it all out to deliver those. Now, this guy over here, he had to have a little bit of slope to it. How about these guys up here? For the cold water line and the hot water line, do they need a slope? Nah, they don't actually need one. And the reason is they can just kind of run through the walls. They could run horizontally. They could even run uphill. If the water has back pressure on it, then it'll go up and down. And you don't want to have an arbitrary number of bends. The more bends you put in, the less efficiency there is in the system. There's more sort of efficiency loss, but it's less restrictive than trying to run the lateral lines. Okay, so with that as an introduction, let's go ahead and actually kind of create our own little mechanical model. I'm going to open up and say New Project. And let's just pause for a second here and think about a potential change we may want to make. Throughout the entire course, I've almost always been selecting the architectural template. Okay, and that's really optimized for doing the architectural work. So now I'm going to actually select the mechanical template. Let me tell you what the difference is. There's not really a huge difference. There's some difference in terms of, the views that are showing up here by default over in the project browser. We'll show you that when we start creating them. There's different disciplines associated with different views, and that changes a little bit. The bigger difference, though, is this notion of really what family parts are loaded into it. And let me kind of show you what that's like. I'll say, open the mechanical template. It'll look amazingly similar to what we're used to seeing, but I'll point out where it's a little bit different. Down here in the bottom, in terms of the family components that are loaded in here, for the pipes and like pipe fittings or ducts and duct fittings, you'll see that in the mechanical template, there's a whole lot more available. So there's all these elbows and transitions and profiles and duct pieces and duct fittings. And you like to have those available because here's the way Revit sort of works. We're going to go through and say we got a fixture over here. We want to take the line to over here. Please help us figure out the piping and all the connections between those things as much as possible. And if it has a fitting, if it has a size available in its library of parts, it knows what to do. If it doesn't have a size that would fit the condition you're trying to do, it'll stop and say, whoa, I don't know what to do. I can't auto-route that for you. So it is worth your while to go ahead and give it a lot of parts to work with and give it the whole Home Depot aisle full of all the parts. That way you can choose anything that's necessary to make it fit. Okay. If you only give it a small number of parts, it'll try to make it out of the small number of parts you give it, okay, which may not always be very efficient. So you generally want to work with a mechanical template, but let's just go ahead and set this up. I'm going to create a plumbing plan on my first floor. Now, in terms of this browser over here, you'll see there's a plumbing section, there's an HVAC section. There's really not much difference again. These views, though, try to filter in and filter out different information based on what you're trying to show in the views. And every view actually has a discipline and even a sub-discipline to it. So for plumbing, we only have plumbing. I could have a separate one for sanitary versus water supply versus sprinklers, but I think plumbing we have there. Under HVAC, you'll see we actually have, or mechanical, we have HVAC as one of the sub-disciplines. You have plumbing, and then plumbing is its own sub-discipline. It's really all just about organizing the views in the project browser. So if sometimes you don't see what you think you're supposed to be seeing, just check to see what the discipline is that's associated with the view. If you're looking for ductwork and you're in the plumbing view, you may not see the ductwork. Okay, so you might need to just change the discipline around. But let's put some walls and things in here, things that we do know will show up. I'm going to put some walls going up to level 2, excuse me. Okay, and I'm not going to be very precise about these walls, since I'm more interested in the plumbing fixtures. Now, to go ahead and create that double wall, just to give myself a little bit of resilience, or a little bit of space that I can work with to hide the pipes, I'm going to put a second wall within here. And again, what am I doing? I'm just sort of creating a mechanical space where I can hide some things. I am ready to start putting components in. So I'll choose components. Let's take a look. I can load some components. I'll go down to the library and find my plumbing fixtures. They're hanging around here. You'll notice, and you probably haven't paid much attention to it, there's actually 2 versions of the plumbing fixtures available. So you might kind of wonder what that's all about. Let's just try, I'll load in a toilet. Like a toilet, I'll do a commercial toilet, a wall-hung toilet. I'll put it on the wall here. Looking pretty good. I'm going to, just as a test, load in the plumbing fixtures. Again, plumbing. MEP, fixture, water closet. Notice we even use a different name for it. I'll put it right beside it. Okay, let's go to 3D and let's take a look, see if we can figure out what the difference is here. Looks kind of the same. Yes?
Is there a standard width that you put the second wall at?
Nah, it's really just as much as we sort of think is going to be necessary to just accommodate the pipes. So in general, if you have like, 16 or 18 inches, that's fine. It's some little piece. Okay, these 2 toilets look amazingly similar to each other. And if I click on this toilet, nothing special there. I click on this toilet. Whoa, something strange happened there. Let's think what happened. This toilet has a few extra features to it. It seems to have some sort of out. Looks like it's an out 4 inches. Looks like it has some sort of water coming to it, a 1-inch water line, and there's something about different numbers of fixture units, okay, in terms of how much is being supplied and carried away. So this toilet and that toilet are just a little bit different. And honestly, that's about the only real difference between the 2. The plumbing fixtures that are in the architectural section of the library are really just the same as the ones that are in the MEP section of the library. But the MEP ones have been loaded up with some additional inlets and outlets to help you design a system around them. So if I even go through and see what the difference is, I choose to edit this family. Let's let that open up. There's my toilet. Okay. You'll see there's actually a couple of little circles kind of hanging around in there. And those are indicating the in and out locations of the toilet. So you'll see that over here at the back of the flush valve, there's a little circle. If I choose it, we have a sort of a classification to it. It's domestic cold water. We have some sort of radius to it. Down here where the drain line's coming out, we have a connection to something that's considered a sanitary connection, okay, and a radius to that one. You can take a look at the properties of the toilet. For example, here's where we say the number of fixture units. If you wanted to put different diameters on here, we could. It's all really just determined parametrically. So there's really just this sort of funny notion of connections that have been added to it. And in the same sense, we've been going through and, we put together some parts in the last assignment to go through and create different types of families to serve different purposes. If you wanted to kind of take one of your families and start adding system components to it or system connections to it, it's really easy to do. There's different types of connectors. There's an electrical connector, there's kind of an air handling connector, there's a plumbing connector to it. So for example, if I wanted to say that this toilet had a hot water connection, which it doesn't, but just as an example, I could go through and see if I can make this work. Choose a system, let's say it's domestic hot water. See if I can put it on the face. Doesn't look like it wants me to put it on that face. Hang on just a second. Let me just set the work plane. I'll put it on that one. I'm going to think about why it won't let me do it right now, because it should allow me to do that. Let me try doing it in like a different view as opposed to doing it in 3D. Let me see if I can put it in the right side view. Create pipe connector, round connector, part type. Let me do it. It's interesting. I'm struggling with why it won't let me do it right now, because it let me do it this morning, but there's something and I can't see what it is right offhand, which is just a little bit different. Try one other thing, and then I'm not going to stress on it. Well, there it is. I put it on the work plane. That's a very big connector right now. If I want to only put one that's about an inch in radius, I could kind of shrink that up and push it over to whatever the location is supposed to be in. So I put it on the floor as opposed to the fixture. Let's see if we can make this work. I'm hard-headed, so we'll see if we can actually make it work one more time. On the face of this. Oh, looks like I got it that time. Okay, so now for better or for worse, our toilet does have a hot water connection to it. Okay, you can go through and add a water connection or an electric connection to any of the parts that you put together. It's really just a matter of sort of putting those connectors on, and then it becomes part of a system. But enough of all that fooling around. Let's go through and actually sort of, okay, given that we want to use these mechanical ones, these ones that came out of the mechanical system, put some more of them in here. Now, a shortcut, just to make sure you get the right ones, is you can go through and when you choose component, you'll see that, a whole bunch of different components are listed here, all sorts of different categories. If you go to the Systems tab and choose Plumbing Fixture, what you're going to get is a much smaller list. There's only the things here which are considered plumbing fixtures, so of that same category. So someone asked this morning what the difference is between saying component architecture versus system plumbing fixture. The only difference is really that the list becomes smaller. They got filtered down to show you a smaller list of candidates. So we'll go ahead and put this public one in here. I'll put a second toilet in over here. Let's go out and grab some more of these things. I'll say systems, plumbing fixture. If I don't have a nice urinal loaded in here, I might need to load one of those in. So I'll say insert, load a family. Let me see if I can get that urinal, and we'll get the sink in here too. So plumbing fixtures, urinals. Let's get a nice wall-hung urinal with wings, no less. That sounds very special. And finally, let's put a sink in here. So we'll again say low to family. Let's go out there to the plumbing fixtures. Again, I'll go down the MEP path because I want to get the ones that have, oops, let me see if this is actually right. In the MEP world, the sinks are things like kitchen sinks. The bathroom sink is considered a lavatory because we wash our hands. So I'll put a wall-mounted lavatory in here. Okay, and you'll notice for each of these different fixtures, as we've placed them, there's different sort of inputs and outputs specified for each of them. Yeah, since I'm putting them in 3D, I have no idea if I've been getting my heights right. Actually, not too awfully bad. This one's a little low flying right now. Yeah, that one's very high flying. I'll tell you in a second. Let me do a measure. Oh, I'm in 3D, it won't let me. Okay. Okay, let us stop and consider now how we hook these things all together. Okay, you got the fixtures in there, you got the basic units. The next thing you want to do is actually start just laying out this basic piping system. And how you lay out the piping is really not too awfully bad. We have sort of a nice horizontal space for them. If I go back to that, plumbing fixture plan, I have this nice space in the wall that I'm going to actually go through and put the pipe. If I put the pipe in, I kind of come back in here, and I go to the Systems tab, I can choose to put in a piece of pipe. When you choose to put in a piece of pipe, you have a couple of different choices you want to make about it. One is the diameter of the pipe. I'm going to guess 4 inches right now is the diameter of the pipe because, that's what my gut level is telling me. If we need to resize that, Revit will give me some feedback about that when I ask it to help confirm these sizes. You have the issue of the offset, and that is the offset relative to level 1. So here's how this works. Okay, if level 1's now right here, or wherever the floor level happens to be right now, when you're running a lateral pipe for the sewage, okay, they tend to be fairly low to the floor, or even below the floor, okay, because they have to be lower than the toilets. Things don't like to go uphill. Okay, so we have to have it start fairly low to the floor, or even be below the floor in the ceiling plane of the floor below. Either one of those will work. Okay. As we think about this pipe and what its offset is, I tend to get a very small offset. If this has to be around 18 inches or 19 inches, I'll let this be like 6 inches or something like that. I want it to go down. I definitely want it to go down. Okay. But we have the issue of, as we put the pipe in here, this pipe's going to have a little bit of slope too. So let me kind of show you what the slope choices look like. Slope could either be slope off or slope up or slope down. So as we define the pipe, it's kind of a question of really what the difference is between slope up and slope down is. If I drew the pipe from left to right, I'm sloping down. So I put the offset in as like 6 inches, go down from 6 inches. If I drew from right to left, I'd be sloping up. So I wouldn't want to say 6 inches sloping up because it would grow from that point. It's really the offset you put in is kind of the extreme point of the pipe. I might have to say -1 foot and grow this way. But what you're putting in there, that offset is really from the first point you place. If we continue to grow the line 100 feet, really what's going to happen? Will it keep on going down? You're really saying which is the part that's going to determine the bounding or the boundary constraint. And then the pipe will sort of adapt itself as necessary, depending on the geography or the geometry. So I'm going to put in here, something like 6 inches. And then we'll go through and say, let's slope this down. We get to choose a nice value, and a 1/4 inch or 1/4 inch and 12 inches looks pretty good. I can then just start drawing and pulling on down. I'm going to pull it just past the bathroom. Oh, that's interesting. Let's see if we can figure out why that's not visible. Okay, I've created some things. You may, since this is not going to be visible in our plumbing plan view, you may want to check why this is. And okay, that's that message where I've given it something. Okay, it has created it. I just can't see it in this view. Let's go to 3D and see if we can figure out why. Okay, looks like there's something in there. That's not looking too awfully bad. Oh, within this view, you'll notice when I placed the pipe, one thing I forgot to check was the notion of really what system type it is. When I drew it, I've assigned it to the hydronic supply system, and I don't want that. This is actually going to be a sanitary line. Let me switch that over. I am betting now, when I go back over to the floor plan, it will show up. Okay, so what was the difference there? Let me kind of take that one out and show you, do it again the first time through. I'll say pipe. I'll say that not a hydronic system, I actually want it to be the sanitary system. And then when I draw it, again, it's fighting with me. So let's take a look at what it is. Pipe. Sanitary system, 4 inches, that looks okay. Let me start that at 6 inches up there again. Should check to make sure, are we sloping down? We are. Okay, that time it is. Now, as we draw the pipe there, you'll notice that the pipe sort of represents itself as sort of a big old fat line. That's kind of okay. But this is related to the whole notion of really, the same thing that happens with structural drawings, where if we're looking at it schematically, it may make sense to say it's just a big old fat line. If we want to start to actually think about the space that it's taking up and understand the physical boundaries of it, we can turn up the resolution of this. So right now it's currently set to just medium. If I turn it up to a fine resolution, then you'll see the true width of the pipe. So it's a sanitary system. You'll notice that it's showing up in green. That's because in the mechanical template, if I go to visibility graphics, it's actually kind of interesting. I'll see if that's actually the default for this. I was going to show you a way to kind of control that in just a second. Maybe I'll do that in the 3D view. Let's go to our 3D view. I'm still looking pretty green over there. I'll make it fine. It looks a little bit better. Okay, you can see though how it's moving from up high near the toilet to kind of dropping down below the floor over there. Okay, the next thing you may want to do is actually put together a riser. Put a riser in so you can go through and have that at the appropriate, or tie this lateral into a vertical pipe that's going to carry the sewage away. So we want to draw a vertical pipe. I will be the, this is one that it continues to baffle me in terms of how to control this exactly, but I'll do something and then show you how I always fix it. But I know there's a shortcut for doing this, for doing it a little bit better. But let me show you how I draw these in. I want to draw a vertical pipe in here. And as I'm drawing a vertical pipe, the big question always is, if I'm going to draw an elevation view, how far into the depth are we drawing an elevation on? Okay. So there's always some notion of a placement plane, and what I will tend to do is, well, let me do this. I'm going to switch over to the elevation to the side, say the east elevation. Zoom on in there. Let me even go ahead and make that fine also. So relative to those plumbing fixtures, I have some sense of where that pipe's going to be. I really want to draw it so it's pretty much in line with it. It doesn't have to be in line with that, but it generally makes sense to draw it in line with that. So I choose pipe. I choose it's going to be a 4-inch pipe. Sanitary, that's okay. What I want to do is actually draw on a work plane. So what I try to do is actually set a work plane so that when I draw, it'll be on that plane. But I'll be the first to admit I don't have very good luck doing it this way, but I'll try it and we'll see how it goes. I'll shorten that up. I will draw a work plane. I'm going to say that this is my little risers plane. And why am I doing this? I'm just trying to control where this pipe shows up, kind of in terms of its depth. So there is where I'm going to try and draw the riser. I'm going to go back over to that East Plumbing. I'm going to say set the work plane to be risers, or reference plane to be risers. So with any luck right now, if I draw, I'm going to be drawing on that reference plane. Now, I haven't had good luck with this, so that's why I preface this with if there is any good luck. But I'll choose that pipe. Oh, relative to the pipe, see, it's got that minus 8.5, but I don't think that's really what's making the difference here. I think that's going to control the height. I can draw a riser. Okay, but what happens is when I switch back over to 3D, it's at some weird arbitrary space. Now, I know there is some bizarre trick, and I'll look it up after class, where if I hold down the control key and shift, I spin around twice backwards on my head, I'll get it to draw a vertical pipe in some location. But I'm very bad at doing that. So what I tend to do is I'll just put it in, and then go through and move it. But once I get my risers in, I'm in generally pretty good shape. So I'll take that riser, which is hanging out over here, and kind of move it over into the territory it needs to be. So far, so good. Got the general territory? Super. Let's go back over here. I'll go back to 3D again. Oh, actually, I'm in 3D, aren't I? Come over here. I got that riser hanging around. I got that lateral coming to it. Oh, I would so much like to get those two things together and have them join into a singular system. And how could I possibly do that and have it all happen very auto-magically for me? Let me stretch that on down just so we can make it a little more riser. If you click on a pipe, you actually have this magic little handle at the end right here. And if you grab that magic little handle and pull it over to the point where you are dragging it and it intersects with a riser. Come with me. And you get to the point where it actually would intersect with a riser and let go. It does something very cool for you. It goes through and connects them. You zoom on out again. But it does it in sort of a very special way. Let me put the full navigation wheel in here again so I can center on that. Let me orbit that around a little bit. It does this, which is actually kind of cool. It not only sort of connects it, it actually puts a little fitting right in there. So it's smart enough to figure out that, oh, if you're going to connect two pieces of pipe together, I'm not just going to intersect. I need to put some T-fitting in there that's going to join them all and kind of make it happen together. So let me show you again how I did that. If you're following along, just so you get a sense. I've got the two separate pieces. They're kind of hanging around separate. They're looking okay. If I click on this one and grab the little handle, as soon as I get the two to intersect, okay, it'll try to join them in there. And it will if it thinks there's any physical way to do that. Ways that doesn't work, ways you can go wrong. If you have another intersection that happens to be hitting it at almost exactly the same point so that it couldn't put both connections in, it'll complain and say, I can't route that. Yeah. It has to be something that it thinks it can physically do. Okay, so when you're doing this, about the only way you really tend to get in trouble is if you have a whole bunch of connectors and there's just not enough space to squeeze it all in there and Revit just gets confused. It doesn't understand how to join it all together. It'll stop and balk at that. So it doesn't like the notion of their, if it can't match the physics. So let's pause there for a second. How are we doing in terms of, do you got some sort of basic lateral hanging around in there? Okay. Once you got the lateral, it's actually very, very easy to work with from here on out, because what's going to happen is for each of these different fixtures, all we really have to do is get Revit to connect from the fixture to the lateral. Okay. And you're thinking, well, I'm gonna have to draw a horizontal pipe and a vertical pipe and put the elbow in there, and that's starting to sound like a lot of work. But it doesn't have to be nearly that much work, because you can choose the fixture, say connect it into a system, and say, well, what kind of system would you like me to connect it to? I could connect it to a sanitary or a domestic cold water. I understand both these systems. I would like you to choose sanitary. And then I can choose the sanitary system I'd like to connect to, and it puts the piping in there for you. So it auto routes it. Do the same thing over to this one. I'll choose that guy. I'll say connect it into. I want to connect the sanitary system. Well, which sanitary system would you like? You might have more than one sanitary system. That's why it's asking. Sometimes we subdivide the system into a lot of little separate pieces. Same thing with the urinal. Let's connect that into. And finally, let's go ahead and get that sink. So to start with a fixture, do a connect into. Notice this one has a few more systems to it. Hot and cold water. Now the sink's in there. Okay, so that's the basics of going through and connecting a sanitary system. Now, let's talk about this routing thing. This routing thing, yes?
Do you need to record in the wall or does it automatically?
It doesn't do it for you automatically. Generally, what would we say? That's kind of implicit. If we were very highly detailed, we actually would put a knockout in the wall to kind of allow for that. But honestly, generally, I think we just sort of, we sort of slough that one off a little bit. And we can certainly let it help us figure out where the holes need to be. Okay, so you go through and put the sanitary system in. That's looking pretty good. For the routing that's going on here, let's talk about that. Routing is really all about, from a specific type of fixture and whatever its output is, connect it through to kind of the lateral line, the main line that you want to you have it carry the waste away in this case, and sort of connect in the appropriate pipe segments and connections to make a more orderly and kind of sensible transition between those things. What auto routing is not really great at doing is, if you give it, an awful lot of freedom to kind of make a connection, and there are many different options in which it can be made, it may not always make what you would consider the smartest choice about how to go through and route things. Like if I just took those pipes and I said there's a riser over here, route them together, it might actually run it through the wall and do something sensible like that. Okay, it might just try to do something that it thinks is mathematically a shorter path. So it often makes sense when we're running the plumbing and really most of these things where we start doing routing to, what did I really do here? I said, I know where the riser is going to be because architecturally I want it to run up and down in this part of the space. And I have a pretty good sense of where I'd like the lateral to be, so let me suggest where I think the lateral will be. Okay, I'll let you auto route from the toilet to the lateral, stuff like that. So I would recommend a strategy of what I'll call hybrid auto routing, where you don't give it complete freedom to do whatever seems to mathematically make sense. You use your intuition as a designer to lay out what's a pretty close to sensible path, and then you let it optimize the endpoints to it. Okay, because you'll just get a better result that way. You have a lot of intuition about what you had intended and how the piping would probably make the most sense. Revit doesn't have that intuition. It's just a mathematical equation to it. Okay, so give it a little bit of guidance in terms of what's going on. Okay, now if you like the idea of doing plumbing systems like this, we like the idea of doing lateral or sanitary systems. The other types of systems, hot and cold water, work very, very similarly. In fact, in a way they're easier because with hot and cold water systems, you don't have to worry about the whole notion of slope. They can really run, as long as they have some height where the pipes don't interfere with other pipes, you're in pretty good shape. So let me kind of just get you started on that, and then we can let you kind of keep on playing with that over the break if you want to. So for example, I got my plumbing fixtures. They're all looking pretty good. Oops. Let me tell you what I just did there. I went up into the mechanical HVAC section. I see my fixtures, but I don't actually see any piping. That's because I'm on the HVAC diagrams. Let me close that up just so I'm not looking at that. I want to go down to the plumbing plan, okay, and then I'm seeing the pipes. So watch out for that. If you're running pipes but you're just not seeing them, make sure you're actually in a plumbing view, not a mechanical view. Okay. I got that system, it's looking pretty good. Let me go through and run another pipe in here. In this case, I want to run a cold water pipe that's going to service a lot of these fixtures. I'll put it also kind of in parallel back in that little mechanical chase. In terms of its diameter, I'm guessing like a 2-inch pipe would probably be fine. Again, we can get Revit to give us some guidance about sizing this based on the actual load, how many fixture units need to be fed by the pipe. But I'll choose 2 inches as my starting point. In terms of the offset, this is the offset off of the floor. I'll guess for my cold water, I'm going to run it around like 5 feet off the floor. Again, it's just sort of my guess based on experience. That might be a good height to avoid some other things. Okay, in terms of a system type, it's not sanitary. I'm going to say that it is domestic cold water. Then I'll come on in. For these cold water pipes, slope, it could actually just be slope off. You don't need to put a slope on those. You could, there's no harm on them, but they don't have to be. And I'll just run a pipe back in here. At this point, my biggest concern is really just not having a bunch of pipes intersect each other. So I'll run that pipe over close to where the riser is going to be. You'll notice it shows up in blue because, by default, in the mechanical template, those show up in blue. Let me go ahead and even run a third pipe in there. I'll say pipe. It's going to be my domestic hot water pipe. Okay, and this is the feed pipe for the system. This one I could leave it at 5, but if I put the hot and the cold exactly at 5 feet, every time I'm trying to go towards the fixtures, I'm going to run into the other pipe. It just doesn't make a lot of sense to put them at exactly the same height. So I don't know, maybe this one's going to be at 4'11" or something like that, or maybe 4'10". Yeah, your plumber will appreciate it if you give them a little breathing room so that they don't have to be right on top of each other. So I'll apply that. I'll put that back in here somewhere. Notice that one shows up in red. Okay, so I got 3 different pipes running through my system here. Let me go back to 3D. Let's join some more units. So I got that toilet over here. I would like to join it in. I got to find it's under the layout. It's just sort of buried because my screen's squishy, so you can't see it right off. Connect into. Okay. Notice it doesn't ask me anything at this point because actually there's only one unit or one system that is not connected. So it knows that, yeah, it must be the cold water because the sanitary is already taken care of. Okay, so I'll choose the cold water system. Now, that wasn't exactly a sensible routing. Go back and fix that later. It decided the end of the pipe was so close rather than teeing into the pipe. Why don't we just run it around to the end of the pipe instead? Okay, which is not necessarily a useful assumption. Let me connect in the other one. Went to that end of the pipe. It's batting 0 so far. Okay, that doesn't look very good. Let's try the urinal. I'm dying to see what it tries to do with this one. Now that wasn't so bad. That actually sort of did about the right thing. It came straight up. How about the sink? Okay, the sink notice, it actually asked me because it could be you want hot, you want cold. I'm going to route the cold water to the sink. Okay, and that did a pretty good job. So it seems like the problem spots are these endpoints. These endpoints are to get us in trouble. So not to worry. If we're not happy with what it did, we can always go through and change things. So for example, this one we didn't like because it kind of ran it out back looking pretty good towards the pipe, but it decided to go a little haywire on the end. Okay, if you don't like a part of a segment, you can remove pieces. Over here. Okay, now I just got that straight out piece. Let me try this. What happens if I try, that's all the analysis. Let me try this again. I'm seeing if I can join this right. I'm thinking about if I can get it back to do the connect into again. And it may not be, although I think it should be able to. The worst case is I'm just going to draw a pipe and it's going to connect in. Let me try taking that out and just try connecting again. Okay, that time it actually did it. It's kind of interesting. Okay, let me try taking out this piece over here. So what is it doing? It seems like I had to take out the pipe. I probably, as opposed to letting it roll, I should have had done it this again the second time, or right at the time when it first made the error. Let's choose this one, say connect into, and then it's back in there. There's definitely this notion that as you put more connectors on the pipe, it starts getting a much finer idea about what the realm of possibilities are that it could connect to. Okay, so I think because it was capped on this end, and ultimately we capped on that one, like this one, for example, decided rather than going ahead and going all the way to the end, it would make sense to just kind of insert it in that shorter segment there. Okay, similar sorts of things over here. You'll take that guy. Let's connect it into the hot water. Again, not doing so good there. Actually, let me kind of talk about one way that I do know improves its performance. That's the whole notion of, well, I guess what it doesn't like, or what seems to create the most problems for us, it's what I'll call, it's open-ended pipe caps. It's those open ends where there are uncapped pipes that are just kind of hanging out there. So the solution to this problem, or a very good approach to this problem, is to do this. You gotta shrink those lines just to make it a little bit easier to see what's going on. It's a little transition left over. Okay, if you go through and say, hey, I got that riser over here. Once you have one riser, the good news is it's actually really easy to go through and copy them. That's actually good because it's running vertically. Let me change its type to be the cold water riser. 4 inches is probably a little bit big. And as long as I'm getting the cold water riser, let me duplicate that. I'll make that the hot water riser. So with those risers, let me kind of flip that over. I can do the same sort of thing I did with the sanitary pipe. I can go through and take that, pull it on over as soon as I get it to intersect. That's no longer an uncapped connection. It has some sort of T there. Let's take this guy over here. Gonna pull it all the way down. See if I can get it to connect to that. Looks like it's not quite connecting to it. Or what's happening is it's a little bit offset, kind of in the XY direction. Just back that off a little bit. I could add another pipe connecting those things. So at this point, I can either move the riser to be in line with that, or I can add a short pipe segment from this end and tie it in there. Either way I would like. Okay. If I wanted to do that, I could say, let's choose a pipe. It's a 2-inch pipe. It's going to be domestic hot water. I can just grab from here and pull it over. to what I wanted? No, it looks like I'm off. To the edge. Looking like it may be too short. Try that again. Again, if I'm going to get in trouble, it's because the physics just aren't quite right. Here. Okay, that did it right. Small transition in there. So again, just choose whichever way seems to make the most sense. Whether you want to put a bend in the pipe or kind of move the riser location. But the fact was, now that we go through and we have these pipes capped, now when you go through into your connections, of course it's, okay, how sensible or non-sensible is that? Okay, it's running it all the way down there. Okay, you're feeling my pain. I can tell you're feeling my pain. So what I should do, if I really want to be smart about this, is as follows. Let's pull you out over there so I can see this for a second. You're an open-ended pipe. I should really put a cap on the pipe. That's another way to approach this. Let's see if I can figure this one out. Systems, pipe, placeholders, fittings, flexi pipe. Try a pipe fitting. I got elbows. I got a cap. Ooh, I like caps. Caps are a good thing. I think that one already is capped over on that side now. Yeah, that is some sort of transition on it. Okay, with my pipe capped, I will choose this. I will lay out and connect that. I will choose this, and yes, finally. Okay, so what is our lesson? Okay. The high-level lesson is, if you don't want to mess around like I do and make a lot of mistakes along the way, get that lateral across the way you want, and then go through and don't leave any like dangling open-ended pipes, because it seems to prefer those. It thinks they're really, really attractive, even if they're very far away. So either cap a pipe to stop that behavior, or connect it into a riser, because that'll do that. Just don't leave any just dangling particles in there. You don't want to have open connections at the tail end that might sort of invite the connection to do the wrong thing. Okay, let's go ahead, break there in terms of what's going on. I'm going to talk a little about air handling, but we'll continue that next time.